Ladies and gentlemen, and welcome to the next video in this presentation on waves and light. This is presentation number 5. This video today will conclude our unit in waves and light. So in this video today, I want us to be able to do a few things. I want us to be able to explain the behavior of light known as diffraction, the behavior of light known as interference, and the behavior of light known as absorption. At the end of the day, you should be able to explain each of these behaviors. This is where your slotted notes begin. It left off right after refraction from yesterday's or the last video that you watched. So I believe this is page 9, or the bottom of page 9. So we'll begin with diffraction. Okay, now just to give you a little bit of review, the last video we talked about reflection and refraction. So reflection was light bounces off of an object and goes back to your eye or another place in space. Refraction is when light passes through one medium and another, such as air and water, and when it does that, it slows down. And when it slows down, it actually bends, right? So reflection and refraction are the first two that we talked about. Today we're going to begin with diffraction. Now, diffraction kind of sounds like refraction, and it's another bending of light, but this diffraction is when light bends around a barrier or an opening. I think the most common one that we can think of is when light bends through clouds or blurry edges of shadows. If you look at this picture here, okay, up at the top right, we've all seen these clouds type this before. When light jumps through, or not jumps through, but passes through around the cloud. See, it all. If you look at this picture here, you see that the light travels in smooth waves all the way till it gets to that object, which in this case is the clouds. Now, when the light hits those clouds, it passes through the openings, but then you see how it's changed. It looks more like a convex or concave, like a Wi-Fi signal is what most people say. So diffraction is when light bends around a barrier. So here's the barrier. It goes here, it hits the barrier, and it bends, and then once it goes through, it expands and goes in all directions. Okay. Now, longer wavelengths, red, bend more than the opposite of refraction, which is violet. So red, the color red actually bends more than the color violet, because violet has really short wavelengths, but red has long wavelengths, so it's able to bend a lot more. Here's just here are some diagrams for you to see about how refraction affects light. In this very first one, you see that it has a wide gap, and it actually only bends it very, very small. Like the bend in the light waves are very minuscule, very small, and that's because the opening is so large that the light has no problem passing through, just a little problem passing through, not much. Now, if we look over here to the right, we have a narrow gap, very small opening for the light to go through. Now, that is when the light bends greatly. The light bends and goes through there and is not magnified, but just bent in a certain way where it's shining like a flashlight, so to speak. When you turn a flashlight on, it only shines a beam of light toward whatever you point it at. In this case, when it goes around a cloud or around an object or through an object, what is happening is it's narrowing that focus, so that beam of light only goes through that opening and only hits a specific point on the other side. All right, so if we have large wavelengths, remember the wavelength. When I say wavelength, what I mean is when a transverse wave, we measure a wavelength from crest to crest or trough to trough. Now, when those wavelengths, if they're large, then you're going to have a large diffraction. Okay, common sense. If you have a small wavelength, such as violet, like the color violet, then you're going to have very small diffraction, right? So Large wavelength, large diffraction is going to bend a lot more. If it's short wavelengths, then it's going to not as bend as much because it takes a very small gap for it to get through anyway. All right, the next form of behavior that we're going to study is interference. Now, when we think of interference, we need to think of the word combining. Now, combining is we put two or more things together, right? Well, interference, we're taking two or more light waves in the same place at the same time. All right, so remember when I say light waves, right? So this is the wave of light. So some have different wavelengths. Some have more amplification. Some have more frequency. But when we have two in the same place at the same time, then we get interference. They combined. Okay, so look at this chart over here. We have two different wavelengths, all right, and we combined them, and we get an amplified form of that wave. All right, so that means we get more of it. So, example, bright and dim spots of a light. So, if you look at a light, or you look at some of the incandescent lights are better like this. LEDs are more uniform. They have a better coverage. I got an LED flashlight for Christmas, and it shines like a spotlight. There's no dim spots in it. It is a bright light all the way around in a circle. Now you can magnify that light, make it smaller or larger, but there's no dim spots. Now incandescent bulbs, you can notice that there's a bright spot in the middle, and then there's dim spots all the way around it. Okay, that is when interference happens. And we combined those light waves. Hope that makes sense. If it doesn't, shoot me a question, shoot me an email, I'll answer for you. All right, so interference can be constructive, means it can help, right? So amplitudes are added. When amplitudes are added, waves are larger. So that means constructive, it's brighter, right? So if we increase the amplitude, we increase the energy. We increase how much energy the waves carry. So in some instances, okay, interference can be helpful. It can make the light brighter, right? But just as the opposite way, interference can be destructive. It can also subtract amplitudes and make it dimmer, right? So if look down here at our chart. So if we look up here at the very top, what I mean by destructive, they're out of sync. You see how they're out of sync, these two waves? So that's what's making it dark. That's what's killing the light. That's making it dimmer. Is because they're out of sync like this. Okay. Now, if they're in sync with each other, see how they're very close to each other. So they're kind of raising the amplitude of that wave. So when the amplitude is raised, we add more energy, right? More energy means a brighter light, right? So that's when interference can be constructive. So interference can help us or hurt us, all right? So that's really all you need to know, is that it can be destructive or constructive. And is that when it's constructive, lights get brighter. When it's destructive, light gets dimmer. And they're usually out of sync with each other when it's destructive. Now, absorption. Absorption is just exactly the way it sounds, right? It's taking in, it's absorbing the energy that the light is putting out. And this is the most common one, right? So remember, think back to our last video when we talked about color, all right? We talked about the color of a light wave. All right, now we said we see the different colors of like our shirts, clothes, chairs, objects, because light goes to that object. All the colors that are in the light go to that object, but only the color we see is reflected, right? So if I'm wearing a blue shirt, it's because the light hits my shirt and absorbs all the other colors, but I only see blue because that is the light wave that is reflected to my eye. Okay, so absorption is the most common behavior of light, I would say, because if you shine a light on anything, it absorbs all the other colors except for the color you see. So when a beam of light shines through the air, particles in the air absorb some of the light's energy. As a result, the beam of light becomes dim. Okay, that's just, I mean, when you take away energy from anything, it becomes less powerful, right? So if you take away the power of a light through the air absorbs that light, sucks some of that energy out of it, then it becomes very relaxed, very dim. And it can cause things to feel warm. So, I mean, think about today, or maybe not today, but whenever you're watching this video, during the winter time, it's really cold outside. So when it's cold outside, you feel the cold on your skin, right? But when you're inside your house, and let's say it's a sunny day, right? And so, but you know it's cold outside, but you walk to a window in your house that the sun is shining through, and you touch it with the back of your hand or just your regular hand, just the front side of your hand, and you feel that the window's warm, right? Well, why does it feel warm? Well, we know that the sun is shining light there, and light brings thermal energy, and it also travels in waves. We know that, right? So the window is absorbing some of that energy, and it's causing the window to feel warm. Okay, so even though it's cold outside, we still feel the energy of that light because the window has absorbed some of that energy. And that's just a common practice because that's how we warm. That's why it feels so hot outside during the summertime too, because you're outside and the sunlight is beaming down on you and you're absorbing that thermal energy. So that's why we go hunt some shade or take a cold drink of water. Light can bring us a lot of things: color, heat, sight. We can see. So yeah. So hopefully you can make a connection with that. Now this chart just reviews the types of behavior of light. Here are all 5 given to us with definitions and easy ways to remember. If you remember, reflection is when light bounces off of an object, and the ways to remember that word is bouncing. Reflect means to bounce, just like a mirror, right? So we look at ourselves in a mirror and we see our reflection. Whatever's looking back at us in the mirror is light bouncing off that mirror to our eyes, and we see a reflection. The next one is refraction. Refraction, remember the word bending, right? Bending. So we refract light, and light bends, it refracts when it passes from one medium to another. And light will, remember the speed of light is very, very fast. And so when it passes, it travels faster through air than it does water. So when it travels from one medium to another, one state of matter to another, then it slows down, which it causes it to bend. Now, an example of this is whenever we have a straw in our water glass or a pencil or whatever, and it looks like it's broken or bent in the water. We know it's not because we pull it out and look at it, but the way the light shines on it causes it to look bent. The next was diffraction. We talked about diffraction. Remember, it's bending around or bending through. Now, it's not just bending to be bending. It's actually going around or through in a barrier, right? So think about clouds on a light, partly cloudy day when the sun's shining through, and you look up there and it looks like beams of light are shooting off in different directions behind the cloud. That is when diffraction is happening. Okay, so light's bending around an object, and it's causing it to focus on a specific area. The next was interference. Now, interference, we can remember that word as combining. We take different wavelengths of light and we combine them. Now, the way we can remember this is like, think about when you're shining a flashlight and you see bright, dim spots of a light. Okay, so around the outer edge of the light, it looks dim, and right in the center, it's bright. That's because the interference of the light waves causes one area to be bright, one area to be dim. And finally, the last one is absorption. All right, so absorption. The transfer of energy carried from light waves to particles of matter. We can remember this by taking in. All right. Now, the example is just shining a flashlight. Well, a light just hits the object, and then that object absorbs all that light and then reflects back the color you see. The way that you can remember this is when a very warm window during a cold winter day. If the sun is shining on a winter day and you're inside your house and the sun's shining through the window will absorb some of that thermal energy and cause it to be hot. So, to summarize this video, light moves in waves, and it behaves in one of 5 different ways. It'll reflect, refract, diffuse, interfere, or absorb. I feel like I've talked about that in a previous slide, and each one of those causes light to do something different. You know, reflection causes it to bounce back. Refraction causes it to bend. Diffuse causes it to go around an object or bend around an object. Interfere causes them to combine with each other, and absorbs causes the light waves to lose some of its energy because it is absorbed through different objects. So that is this video presentation. Use this for your knowledge. In the next, I'm going to continue this video. If you want to stop it here, you can. The next part of this video is going to be review of this light waves unit. So hang around and we'll continue. So I wanted to put on this video some review words or review pictures. I'm going to show you a picture or a word, and then you tell me, or you tell yourself, this is just practice, which one of the 5 behaviors of light is happening in this example. Okay, what I'll do is I will put it up. I'll give you a few seconds to answer. I will say the answer and then move on. When you're doing this, you can actually pause the video and answer yourself. Okay, so you don't have to wait on me. You can just pause it and move on. All right? Starting with the first one. Let's move ahead. All right, so bending. Which one of the 5 one of the 5 behaviors of light? This one's refracting. Okay, refracting. So refracting causes it to bend. You could even say diffusion, because diffusion causes it to bend as well. What is this a picture of? This is a picture of reflection. What is this a picture of? This is a picture of refraction. Bending around or through. Like we said, this is diffusion. So it has to go through or around a barrier. What is a picture of? This is diffusion. This is when light passes through a cloud and is focused on a certain area. Bouncing. This is the behavior of reflection. What does this do? Okay, what does this picture do to light? If you remember, we talked about this during the refraction period. It refracts light. And bonus points if you can tell me what kind of lenses are in it. Is it convex or concave? And these are concave lenses. Concave. What's going on in this picture? So this is reflection, all right? So this is reflection, but it's not a smooth surface, so the beams of light are going every which way. All right, but it is reflection. What's happening in this picture? Okay, this is diffusion because light is having to bend through a barrier. There's a small opening and a large opening. Light's having to go through it, but it's bending the light, so that's diffusion. Which one is the taking in? That would be absorption. Absorption. What is this a picture of? This is a picture of a behavior of reflection. If you look at the lake, you can see it's almost a mirror image of the mountain and the sky. So what is this a picture of? All All right, this diagram showing us the behavior of refraction. That is correct, refraction. Because we're passing through medium 1 and medium 2, it is moving away. Now, here's the question. What are the two mediums? Which one's air and which one's water? Is it moving from water to air or air to water? This is bonus. Okay, so if you said it's moving from water to air, you are correct. Because see, it moves away from the light, from the original beam. If it moved down, it would actually slow down. This is actually speeding up. So water starts out and then it speeds up as it leaves. Here's another picture of refraction. That is correct, refraction. So we see that when the light waves move from water to air, or air to water, depending on what perspective of the animal we're looking at, then it slows down or speeds up. Okay, remember this one? We just went over this. This is actually a picture of interference. Okay, so when interference happens, we can have positive interference, which is down here at the bottom, or we can have negative interference, which is constructive or destructive. Okay, what is this a picture of? Now we know it's a magnifying glass, but what kind of lens is it? It's a concave lens. I'm sorry, convex lens. Excuse me, convex lens. But this, it's a convex lens, but does it refract the light or does it reflect it? And it actually refracts it. It bends the light so it magnifies the object. This is a picture of diffusion. Yes, diffusion. I want to give you a second there to pause the video if you wanted to answer this, but light is having to bend through a barrier, so that barrier is causing the light to diffuse. Oh, remember this one? This was that camera in the convenience store. Remember which behavior this is? It is actually reflection. Yes, reflection. It's reflecting what is happening in the store for the camera. Now, bonus points. Is it concave or convex? This is actually a convex mirror because it looks exact. It's just exact replica, just backwards, like a mirror of what is going on. Oh, we got an upside down picture. Okay, this is refraction, right? This is refraction, and this is actually a concave mirror or concave lens because you can see he's taking a picture of himself, but he looks upside down. All right, here are the two lenses. Now, we'll say the one on the left is image 1, the one on the left is image 2. Now, can you tell me which one is which? Which one's convex and which one is concave? So the one on the left is convex and the one on the right is concave. We know the difference because the convex is narrow at the top and fat in the middle, and the concave is wide at the top and bottom and narrow in the middle. This is a picture of reflection. That is correct. For those of you who answered reflection, it is reflection. Okay, so this is this is diffusion, right? Diffusion. And because the object has to go through a barrier, bend through a barrier. See how they start out straight, but then when it hits the barrier, it bends through. Bends through. All right, this is a picture of, right, you guessed it, refraction. We can tell because the pencil is broken. It looks broken, but it's not. It's just the light is slowing down when it hits another medium. Another picture of refraction. That is correct. This is refraction. This is a picture of reflection. Correct. Reflection. We'll give you enough time there to pause it if you need to. Plane waves. So plane waves mean straight and flat, but then it bends through this barrier, and then it's out on the other side. What is the picture of? Example of? Diffusion. That is correct. Here's another example of refraction. That is correct. Okay. So we have light going through from Jill to Jack, but her line of sight is blocked. So light is passing through this barrier, but it's bending. That is known as diffusion. Here is another example of diffusion. You see, as soon as it bends through there, it starts going in every direction, spreading out, and it loses energy as it goes. This one is Jill trying to see her line of sight to Jack, but light is passing through this barrier, but it's bending as it goes through. This is known as diffusion. Okay, so this little girl is doing a science experiment. She's raising it up and raising the rope up and throwing it down, causing a wave to go through. But as you see, the wave hits the barrier and it bounces back. Oh, the wave hits the barrier and bounces back, and she gets some, what is that known as? When it's something that bounces off and comes back to them, what's that known as? That's known as reflection. Okay, we have some barriers here that the light's going around, having to bend around specifically. That is known as diffusion, right? If there's barriers in the way and the light has to go around it or through it, then and it bends that light, it's known as diffusion. Okay, so here we have light waves coming down, hits the water, and then they're bent straight down. What is the behavior known as bending? That is refraction. That is correct. Okay, here we have two openings, right? Two openings. So the first part of this, there's actually two behaviors going on here. Can you tell me which two behaviors are going on here? Looking through this picture. We have two barriers that the light's having to bend through, and when the light's coming through, they're actually combining with each other. So if they're going through there, that's known as diffusion, as it bends through the barrier. When they combine with each other, that's known as interference. Okay, here's our bent object in water again. That's known as refraction. Yes, it's bending. This is also refraction because when white light hits a prism, it bends and you see all the colors of the rainbow. It slows it down, basically. So all that white light slows down, and then we can see every color of the rainbow. Now, this is a diagram, very intricate diagram of reflection. It's very complicating saying how light comes in and light bounces off. And the angle of incident where it comes in is the exact same as the angle that it leaves. So that's the end of our review for this behavior of light. Hope you gained some knowledge from this. Thank you for participating. Don't forget to like and subscribe for more new videos. Thank you for participating. Have a wonderful day.